1, fight!
Hi guys, and welcome back. Well, this is starting to be a bit of a slog. I'm up to part 3 now. Mind you, part 1 was a wee bit of an upgrade video for the machine to make it easier to work on. But this is the second part of the power supply, and it's not getting much easier. A few issues, a few things found out, and hopefully, if not this one, I'm hoping the next one, there will be an outcome to this. There is a Zener diode on this power supply, which is not common now, and I have tried what they recommend as a replacement for it and had some weird voltages come out of that. So I've put the original one back in and I've dropped back down, so I think it is fine. But if anything, and I need to get one of those, then I'm going to have to wait till I can get one, probably through eBay or something like that, as AliExpress and that don't sell them. So guys, anyway, I will show you where we're up to and what we are doing. So get yourself some snacks, a drink, and that old comfy chair. And let's get on with it. Okay guys, so I've used a whole pile of desoldering braid, which I got cheap on AliExpress or Temu, one of the two. But these are such a heavy diode that the desoldering gun, I would have to change the tip over, and it's not the size tip I use very often. And I don't like using desoldering pumps, as I've said before. So what I've done is I've used desoldering braid. It's a little more work, but it saves you having to muck around. Now these are all nice and loose, these 4. Now these are the first 4 I'm going to do, which is D1, 2, 3 and 4. I've got the component analyzer here, and what I want to do is pop these out and check these diodes to make sure they're okay, because 9 volts AC coming into here, we should not be getting double the voltage out. We shouldn't be. We should be getting maybe a slightly higher voltage, but nowhere near double the voltage. So what I'm going to do is I'm just going to lift these out one at a time, and I'm just going to check them to make sure they're okay. These are 5402s. So what I want to do is we want to put a, I don't think it's going to fit, so I'm going to have to make a couple of leads up for it, I think, because that's not going to reach. There was a little adapter for that too. I could try and remember where I put that. But anyway, what I will do is get a couple of leads, and we'll sort out a couple of leads for it. Be right back. Okay guys, I got it rigged up, a couple of crocodile clips and a couple of wires into the anode cathode on the tester, and we'll just turn her on. The battery's flat, so I've got to have it tethered to a power pack. Let's put that on. Okay, it's saying it's a Zener diode, anode to cathode, so that's the way it's going, which is right. And yeah, it seems to say it's okay. 3.77 volts. I don't know, they're not a Zener diode, are they? Hang on, let me have a look. It's the IN 5402. It's a silicon diode. Average forward rectified current is 3 amps. No, that doesn't look right. No, that does not look. It's just a silicon diode. It's not a Zener. It may have been getting upset with it, maybe. So we'll try a different one and see what we get with that. The only problem, there's such a hard leg on them, getting them out and then getting them back in again. It's going to be a bit of a mission. No. I thought this was going to be what the issue will be. Mind you, they're not an expensive diode, and if need be, we can change them all one after another. We can actually just replace them, just to be 100% sure. Alright, we'll stick this one on, give this one a go, and see what happens with this one. Okay, that was testing and then come up and said it had an issue. No, it says it's damaged or... Okay, so 3.82 volts and then it's kind of damaged. Okay, so this diode is not good. And this is what I was saying to you, whether there may be an issue with some of these diodes. We'll put that one that side. Because as I was saying, we should get a slightly higher than 9 volt in, but we shouldn't be getting double the voltage. There's no way we should have been getting that. We'll try this one and see what we have. And this one's coming up the same. It's damaged. So it looks like it's the part of the inner two diodes, which is 1 and 2, that may have had an issue. And that's what I'm saying, with these here, it's probably just as easy to replace the whole lot. Because if those two are gone, and this one's sort of like the other one, but it's saying it's a Zener, then maybe these have been damaged as well. Yes, it's testing this and it's saying it's a Zener. So I think the two outer ones are fine. The two inner ones are what's gone. But I think for safety's sake and peace of mind, I'll replace all 4 of these. I will test these other 2 diodes. I think these are going to be running the same. And I mean, if they are, we had about 9 point something volts, where it should be 5 on here. I might just, if these are the same, replace these as well. And that way then I know all these diodes are fine. It may have been a bad power supply that went into here and the voltage rail was too high and it's taken it out. It shouldn't have. These can run like 200 volts, so something catastrophic's gone through these and caused them to do that. Reverse voltage maybe, or too much current. As I say, someone's mucked around with this board, so yeah. And that is why this transistor probably went as well in here. But I'm just wondering maybe, yeah. I'll try the diodes first, because I'm thinking that if it's gone through here, what else has it gone through on the circuit? So I mean, it could have damaged this. Yeah, it's come down through here. You know, did it go down through the ground rail, or did it go down? Yeah, it could have damaged this or the capacitors as well. I don't know. 18 volts shouldn't have, because I think these are if they are only 16 volts, then yeah, it could have actually damaged the caps. They may have a little bit of tolerance. I don't know. Alright, so we will carry on with that, I think. And I'll find some transistors to replace these ones. And hopefully that is our problem, or our only problem. But I will... I'm just a bit worried about these 2 transistors here. Since that has gone, it's stressed these or damaged these and these caps. The caps haven't blown, so they haven't boiled. But it might have pushed them really close to their ratings. These have got that horrible glue stuck around them. So I could take that out and test these and see if they're any good. Put them on the ESR meter and see if they're any good. That might be the other thing I can do. I mean, that cap looks like it's had a bit of a belt in the side, but it looks alright. Alrighty, I'll catch you shortly. Hi guys, and so I've removed the diodes and I tested them on the tester. Now 2 of them said they were good. And these 2 come up with unknown component, whereas these came up as a Zener diode of sorts. Then this one, when I tested it, would sometimes come up as a Zener diode, but most of the time come up as an unknown. So I've decided these 2 consistently came up okay, but I've decided that I'm going to replace all 4 of these, which I have done in here. And just that one of those is a bit iffy, I feel better replacing all 4 of them. Now I didn't have the exact one. Now these are a 1N5402. I didn't have any of those, but I did have the 5408. The difference being is that they're all the same amperage. It's just that the 2s are a 200 to 220 volt voltage. The 8s are 1000 volts voltage. That's what they can handle. So the 8s will be exactly the same. It's just that they have a higher voltage they can handle. And I did it with braid because my desoldering gun, I would have to change the tip to do these bigger legs, and it's not something I do a lot of. Most of the stuff I do is small legs, so I decided to use up some desoldering braid and do it that way, and it came up nice and clean. And as you see, they're all soldered on the back here. They look nicer than the factory ones. So what I do is I cut all the legs off, as I've said before, and once I cut them off, then I touch them up with a soldering iron again to make them so they're not sharp out the other end and they can short on anything. It just rounds the ends over a little bit. So I've got all those done now. Those 4 are in there. I'm thinking about popping out the 12 volt ones as well, which are these 2 down here, and testing them. I've only got one more of these 08s left that I could put into this other set. But as I said, 2 of these tested good. So I mean, if I pop these out, and it's not a lot of work to desolder them, to take them out. They drop out really easy once they're desoldered. These will be easy to get in because they're away. Where they're all around these other components, these are really hard to get back in. These ones are actually not too bad. They're in a lot more open area for me to get to. So I may do that. I think while I've done these 4, I might as well check those. I have got a whole pile of these, a whole series of these coming in from the 5400s up to the 5408s. I could have gone higher, but I don't deal with a lot of the 1000 volt stuff. So I mean, the lower voltage ones will be fine. These I think I had for something else I had to do for somebody, and I've had them ever since. But anyway, I think I will. I think I'll take these out and I'll test them. And once I've done that, I'll come back and I'll let you know how I got on with these ones and if these showed okay or not. These worked as a bridge rectifier, whereas these ones aren't. These are just taking the 9 volts from AC and taking it down to a DC. So we should get probably around about 11 volts off the 9 volt AC, somewhere around there, 11.5 volts. We should be getting on that. So I'll pop these out and check them, and then if they look a bit dodgy, I may replace them with these 2 good ones, and then at least these are all the same. They're all 6 of these with the actual same diodes, so I can do that. I mean, I could probably look for some pulls off of a power supply or something like that, but I know these ones tested good, these 2. Every time I tested them, they tested good. So I can reuse those in here. And it's a lower voltage coming through that than this one. This one's a higher voltage because this one is taking the 16 volt AC and dropping it so it can get the 12 volt plus and minus, whereas this is taking the 9 volt AC and dropping it down for 5 volts. So this one will be a lot more forgiving than this one will. Though even if these are very marginal, at least they'll work. So I will do that. I will pop those 2 out. I'll check them on the tester and see if they're okay. Alright, I'll be back when I've done that. And as I was saying, guys, is when you're desoldering these with desoldering braid, a lot of people don't know how to use desoldering braid very well. The best way I've found in doing these big heavy components is that when I get the desoldering braid and I'm going to do this leg here, I make sure I have about 1 centimetre past the pin. Then I come in with the soldering iron and I push it on the braid and then to the leg, and then it will heat up the solder and it will start wicking up the braid, and I just slowly slide it along the leg, and as you can see on there, it soaks up the solder. I find it's easier doing it that way than it is trying to move it along a little bit at a time. And I'll do the other one at the back. Now you might have to do it a couple of times depending on how much solder is on these pins, and some of these big ones do have a lot of solder on them, especially when they're on the ground planes and places like that. And usually I find by the second pass through, the solder's just about all gone, and you should be able to just about rock the pin in its socket. Yeah, that one's hardly picking up any. Yep, I think those ones are fine. So what I'll do is I go my finger behind and give it a wiggle, and I don't know if you can see that. You might see those legs on the pier down here that are wiggling around, and that one next door to it, and those ones are wiggling as well. So that means that they're free, there's no solder on those, and I can push the legs up and down as well. So what we do is just take a note of which way our cathode anodes are on our diodes, and all I can do is pop them out one at a time, and as I say, they come out. These are just a bit warm still. So what I'll do is I'll get the tester, and we will put this one in and have a look. And if these are fine, we can put these back in. It's just that this was, I think, a little bit high for me. Yeah, and this is what the other ones were coming up as. It's damaged unknown part. Okay, so that's what they were coming up as. And then this is one of the ones I pulled. So if we put this one on, and it comes up as Zener diode. See, so this is picking up that this is a good diode. That other one, I could probably check it again, and it may come up as a diode, and it may not. So we'll give that a try again, just in case we had a bad connection, shall we? Put this one on. Now it says it's a Zener. It's a Zener. Yeah, it's a Zener. Okay, so it may have been a bit of a bad connection on that one. So we'll put that one aside, so that one's okay. And as I say, there will be no harm in changing these. As I say, I've got some on order. When they get here, I don't know. So, I mean, I can go and pick some up locally from J-Car or somewhere like that to get the components. But I sort of thought, what I'm going to pay for two of these, I might as well. If these ones are okay, I'll put them back in. Comes up as Zener. Alright, so that one comes up as okay as well. So it says those are okay, and they are working only one way, so we can pop those back in. And our slight voltage differentiation could be, as I say, I don't know what they're doing with this transistor, because this transistor should be, if you look at the board, a resistor. So I'm not sure. So those can go in there, and we can move that out of our way. So I'll solder these diodes back in. As I say, they seem to be okay. That's the only regulator we have in here. These are transistors, probably MOSFETs, but I'm not 100% sure, so we'll have to check those. But also the other thing that's in the circuit is this op amp, and as I was testing this, I was getting no voltages, but that could have been through these regulators. But I'll put these diodes back in and get this soldered back up. Okay, so those are done. So what I'm going to do now is I'll plug this back in and I'll check these voltages that are on here to see what we've got going. So I'll get rid of all this wire. We don't need this solder braid, used braid and legs off these diodes here. And so what we've done is on the schematic here, so we've checked all down here. Is this going to work? Probably not. Oh, yep. So we've done here, we've done that, we've done that, we've done that, and we've done that. So all that should be fine. So coming out of these two here to the first resistor, to the first capacitor, which is a 4700 UF 16 volt, it'll be 9 volts AC regulated to DC. So that should be sitting at probably about 12 volts. So going to that first capacitor, that should be going to about 12 volts. So that's 47. Just have a look to see which one that is, which is that big one. So here's my silver pen. So if we check across here and here, it should be around about 12 volts DC. It shouldn't be a lot. It might be a bit more because there's no load on the circuit. And we were seeing 18 volts DC. Now, if it's regulating it down to 5 volts, I think 18 is a bit high. But we'll give it a go and see how we go now that we've had a reflow of those the diodes and replace those other ones. So go on and on. Okay, so what have we got down here? .4 volts. So that is on our 9 volt rail. So it may double because of AC, so you're getting 2 halves in there, so it probably would be double. So that I think is okay. So from that we also take off one leg goes to T10 and the other leg goes through to, it goes over that, it goes through to the other capacitor, which we see there. So that's our negative rail. That's going along there, obviously. That's 18 volts across that. So that's putting out 18 volts. It should not be putting out 18 volts on that side. To where we go into the transistor, which is T10. Yep, let's go look where T10 is. Okay, so that's T10. Sorry, guys. So this is T10 here. So as I say, you've got to be careful. See how that's the heat sink, and see it's picking up the voltage through there. Now that's still saying it's 18 volts. That says it's 18.5. And that says it's 18.5. And it shouldn't be. It should no way should that be 18.5. Because this is meant to be putting out 5 volts. That's nothing. That'll be the 12 volt one. That's meant to be our 5 volt rail, and that's at 18.7. Nothing. That, as I say, that is wrong. So I'm wondering if it's that transistor that's got an issue. So that should be biasing, or I wonder if it's through T6. Through, it could still be the op amp. I don't have an op amp tester. There are quite a few op amp testers around if you want to make one. I think it'd probably be just as easy to pop the op amp out, put a socket in and replace it, rather than having to wait to build one. Now the diodes, that's a standard 1N4001. That's a 5 volt Zener. Now I've got piles of different voltages of Zeners, and I've got piles of these 1N4000 series diodes as well. 9014 transistor, I'm not sure. I think I have those. The TIP32, I probably don't. But yeah, that's just a little bit weird to me. It shouldn't be pushing 18 volts coming out of the power connector here. Should not be. So I'm picking it's probably either the op amp, it's got an issue. And that says that we should have plus 12 on pin 3 and on pin 7. And that our op amp is here. 1, 2, 3, 4, 5, 6, 7. Okay. Yep. I'll just switch that on. I just want to check which way around that op amp's going. We're here, so pin 1 is down. So we've got pin 1, 2, 3, 4, 5, 7. The 7 goes to here. So 3 goes down to here, which is a resistor and a diode, which is probably those two there. That'll be 3. Yeah, so there goes the resistor, the diode, and earth. Yes, yeah, okay. So that's those. So we'll check for the 12 volts there. So we go to ground, find ourselves a ground. That's as close to ground as we'll get, I suppose. And then if we go to pin 3, that should be 12 volts. Nothing on pin 3. No, nothing on pin 3. And pin 3, 4, 5, 6, 7, which comes over to here. That should also be 12 volts, and there's nothing there either. So there's nothing down through here. There's no voltages here. See if we can pick up the voltage drop across the diode, shall we? Where are we? Here, between ground and there. So there's not even any voltage across that. Or across that. It's like nothing is getting to the 741, because that should be 12 volts in as well. So let's see. I think it is pin 7 should be getting 12 volts in. Is it pin 7? Yeah, pin 7. It should be 12 volts in on pin 7, which we checked, which was nothing. No. So that's our out, and that's our in, I think. I need to check the schematics on a 741, I think. But I'm picking, we have an issue with that, or that is going straight through. So that's throwing us 18 volts directly down to T6. So where is T6? T6. Okay, so T6 is right down the end. Right down the very end by the power switch. So it'll be down here somewhere. I think about power switch. T8. T7, T12. Over here. T6, right over here. Okay. So that's right over there by the op amp. So that's those three in a line there. So what we'll do is we'll see where we're picking up that 18 volts, which is coming down through here. So I've got 18 volts coming down to there. So we'll check that on T6 and see if we've got 18 volts coming into that. Now we want our ground to here. Yeah, and we got our 18 volts coming into here, but we have nothing coming out of there. And that should be triggering pin 6 on our... Yeah, that should be triggering pin 6 on our 741, and there's nothing. There's nothing whatsoever. So I think we probably need to pop the transistors out and put them through the component tester and check those, because it looks like there's one of those could be giving us history, or it could be a diode, or the Zener maybe. But I think, yeah, I think pull out this one, that one there. So I think we need to pull out this regulator, or this transistor here. We need to pull out that transistor there and check it, and then we need to check the diode and the Zener. I think we need to check all those, and if they seem to be okay, then it'll be just checking the resistors, but the resistors don't look like they've actually gotten over hot or anything, so I'm just wondering. See, if it's got to be in here. It's not there, so it's got to be here or here, because we've taken out the faulty diodes out of that. Oh no, actually that's our 5-volt rail. What am I saying? But we should be getting 12 volts into it, and we're not. Okay. I wonder if that's our issue. We should be looking at our 12 volt. I might have this all wrong, guys. It could be because we're not getting our 12 volt. Mind you, we should be getting 5 volts on pin 2, and we weren't. We weren't getting 5 volts on pin 2. Yeah, which goes through a 1K resistor, and that's on pin 2. So if we go to resistor, and what's it? What's the resistor we got? It's a 1K, and that's on pin 2. So we're pin 1, pin 2. I think that's probably it there. What's up? Pin 2. What's that one? Yep. We should go from here to here. That's the capacitor charging up. I'm not worried about that. Why are we getting nothing one way and something the other way? That resist. Oh, that's. What are we looking for? 42. $970. So yeah, that's close enough to 1K. And 41. Could be a 2.2. $2.17, that's alright. 45. I don't know what that is, that's all over, but 45 should be a 22. 33 ohms, that should be okay. 56. Was it 55? 55 should be a 1K. Yeah, which it is a 1K. 56, which is probably that one there, should be a 510. Yeah, 518, 520. Well, all those resistors are in spec. So one's a Zener, which is this one. Yeah. And the other one's a 1N, which is this one here. Doesn't. Okay, maybe we got an open diode. Nothing. Oh, sorry, put it on diode mode. That might work better. I'm not going to diode that way. Nothing that way. So the diode's okay. We'll just recheck that Zener. It's alright that way. Okay. That's ZD3. Which one are we doing? Oh, ZD1. Oh, this one. That's right that way. And high that way. What's ZD3 then? Because ZD3 was giving me some weird... ZD3. It's not a Zener. It's a HZ12B2. I have to have a look at that. That's conducting both ways. And I don't think it should be. It looks like it's meant to be some form of Zener diode, but it's conducting both ways, not like the other one. So the other Zener diode is okay. So okay, so we tested that. That's okay to earth. That's okay to here. That's okay there. That's okay. That's okay. Those two are okay. The connection between the two of those are okay. We need to check that and those two. The capacitor is okay, and that one will be okay. We can pop them out and put them through a capacitor tester. I don't think we need to. That should be fine. But it still doesn't tell us why we're getting 18 volts. And that's why I'm picking it's something to do with this circuit here, why we're not getting 5 volts. And I think if we're not getting 5 volts here, it's probably not going to get 12 volts from here. So it could be the 12 volts coming in that's not causing that circuit to work properly. But as I say, for the sake of popping out the transistors, we can chuck them out and test them on the tester and see if it tells us any different. I mean, it's only a couple of second job to do that. The op amp, other than that, I think we'll leave that until we try and sort out some of this to find out what's going on. So we want T10, which is down here, that one, and we want T6, which is this one over here. Okay, so we're under here, and we're over here. Okay. Alright, I will go through and pull these off and check them and get back to you. Okay guys, so I've just done a check and I'm going to have to ask Stephen if he's replaced any of these transistors, because this one here, sorry, I'll move that out your way. This one here, which is the pt-3, which is a PNP or an NPN transistor, has been replaced with a 7912. So a 12 volt minus 12 volt regulator. That's what it's been replaced with. Why? I have no idea. That's meant to be a transistor in there, not that. I have to have a look and see if I've got any TIP32s. Failing that, I can get some locally. So I may have to look at grabbing one or two of those locally. I may have something equivalent to that. The 9014 tested fine, so I'm going to solder that back in. And I tested that a couple of times on the component tester, and that works fine. And the pins come up pin for pin fine as well. So I'm going to put that back in, and then I'm going to see if I can find any TIP32s. And I may be just checking these other ones too around here for this one to see what this one is, because I know the one in here in the middle of the board is actually a 12 volt regulator. These two were transistors, so that's what I'm saying. I don't know what's going on here. There is something that's not right, but we will get there in the end. So I will go through and, as I say, see if I can find a TRP32 on this and solder this one back in. So I'll be back with you shortly. Well guys, I've got me odd components boards here. These are just power transistors and ICs, etc., that I collected from a chap who was moving overseas, and it was all his dad's stuff, and he gave them to me all on these static boards. I've been through all my transistors. I've got some 42s that are a higher voltage, the same current. Higher current. They're a 6 amp rather than a 3 amp, and they'll do higher voltages than that, but they're pulls, so I don't know what they're like. I can put them on the tester, but the legs are short, and because these come up and bend across and get bolted onto the heatsink, I actually want to put new ones in. So I'm going to pop this one out too, because it's not sitting very happily, and check what that one is, and see if the same mistake's been done as this. That is probably why we're getting 18 volts on the 5 volt rail. Not good. Lucky it didn't damage the transistor. I don't know if it's done anything to the op amp. So what I'll do is I can get some of these transistors tomorrow. So what I'm going to do that tomorrow morning. I'll grab a couple of these. I'm going to check this other one to see what that is as well. And I'll check this one to see what that one's meant to be as well. I tell you. But anyway, I'll do that, and then hopefully we can come back to this and see where we're going. But I think I'm going to stop this one here, because this is starting to get a little bit long for what I wanted. I didn't want it to be this long. I was picking that this will be a fairly easy fix and a fairly quick fix. I went a wee bit down the rabbit hole with doing the cables and that, which they're all done, and as you can see, it makes it easier to work on. I didn't realise someone had mucked around with the power supply, and it was not from factory. There were bodge wires all over it, and somebody's destroyed some of the tracks on the back. So I will do that. I will check this and this transistor to make sure they are the correct ones and they haven't been changed for something else. So I will do that, and then I will come back to you when we get further. Well guys, what a tangled web we weave. Anyway, we're starting to get there. There was a bit more going on here than when I first thought, and there will be another part to this, and with help of some other people, as you'll see in the next episode, we've worked out where a lot of this problem has come from. So thank you for everybody who's been helping me with this through the channels and that. And there is some information that will be coming up in the next video about the version 3 and version 4 boards. I've worked something out. Anyway guys, thanks for coming along on this journey. I'm still waiting for a few bits that should be in this weekend, I'm hoping, to replace on this power supply. So until next episode, have a great day, have a great week, and until next time, ciao.